Any questions? No, this is an energy problem. Sorry, premature. All right, so just trying to think of what else to need to do in chapter 6. I think I've pretty much covered everything.
Can you go over the satellite problem again?
The which problem?
The satellite problem, or like,
Okay. Variation of it. I gave you, it was orbiting at a particular, an altitude of the radius of the Earth.
yes. So it's the radius of the Earth, of course, has the radius, and then the radius from the satellite is Earth's radius, but then altogether is just the radius, or like, is that technically?
Yeah, so the radius of the orbit of the satellite's orbiting about the center of the Earth.
Mhm.
And so when you're looking at the orbital radius is that full distance,
Yeah.
not just how far it is above the ground. I assume you want me to just flesh the whole thing out, or does that satisfy the curiosity?
That might, maybe do it.
Good,
Again,
okay.
Yeah.
All right, so as with any of these problems, we have our facades method. Don't put the wrong letter there. Put that in parentheses. All right, so force diagram. We have a satellite here that is in some sort of circular orbit, and we're making it a circular orbit because we don't really have the scope to talk about elliptical orbits. All right, so force diagram. What are all the forces acting on the satellite? Go to our checklist. Is friction acting on the satellite?
No.
Okay, why not?
No air in space.
Okay, and?
Not
That's a
flying
question.
with anything.
That's the main thing right there. Yeah, air resistance is incredibly complicated, so we're definitely ignoring air resistance. Is there air in space? Remember that air is not, even though I will make reference to air molecules, air is not actually an element or a molecule. It is composed of many different molecules. So the oxygen molecules or the nitrogen molecules, I guess those are the two big ones. There might be some out there, but not a whole lot. All right, so no friction. What about tension? Why not?
No room.
Yeah, or change, there's nothing, there's nothing tethered, there's no tether to it. There's no other. Normal force?
It's not touching anything.
All right. Gravitational force?
Yes.
I hope so. If there were no gravitational force acting on it, what would the satellite be doing?
Not sticking around.
Yeah. Just keep going like that. I guess at that point, it's not called a satellite anymore. All right, so there's gravitational force acting inwards. So we've got F sub g there, and likewise, there's a F sub g acting on the Earth.
I didn't know that big ball was supposed to be here.
Yeah, it's supposed to be. We are assuming that the center of the Earth, yeah, well, we're assuming a circular orbit. All right, so we've got, that's it, fourth diagram done. The direction of acceleration.
Is it down?
What about if it's over here?
Yeah, it would be like that way, right?
Okay, yeah. It's always pointing towards the center of the Earth, so my acceleration towards the center. In this particular case, the trouble with down is officially down is the direction of the gravitational force on the small object, so it will always be down. Which I guess is, yeah, okay, down is correct. So my acceleration is in that direction. Anything traveling in a circular path, the direction of acceleration is always towards the center. Done. Coordinate axes. How do you want to set up a coordinate system? It's a rough couple days. Logan, you look like you have an answer.
Positive up and to the right.
Positive up and to the right.
Yes.
Any particular reason why?
Well, one of them lines up with where it is right now.
With one of them lines up with the acceleration or the force?
No, currently. Yeah.
All right. What about this? You said to the right. What forces, do we have any forces acting horizontally for the way it's drawn?
No.
All right. So this one, yeah, you could define it, but you really don't have to define that one. You've chosen up, so that is opposite direction of acceleration, so we need to figure out how we're gonna deal with that. And, all right. If you don't like the fact that it's pointed opposite direction of acceleration, then you should have spoken up. Decomposition, do we need to break anything up? Any other forces?
No.
I heard a very quiet no, I think. Slightly louder, yep, that is correct. Equations of motion. How many equations of motion will we have?
Just one.
Yep. And what is it?
Okay. With F and G,
F sub g.
F sub G plus acceleration, or no. I can't really see it.
In green, that's the only force acting on it.
Oh, is equal to an
What type of A are we talking about?
centrifugal acceleration. Centrifugal.
The other one. It sounded like you said it, but you mispronounced it slightly.
Centrifugal?
Centripetal.
Centripetal.
It's a
Okay.
T there. All right, so we've got this issue here, now we have to deal with our coordinate system, the fact that we said a way was positive. If that way is positive, what should the force here be?
Negative.
Yeah. And so now we're left with this acceleration.
But then,
What-
why is it f of g if it's like f of g minus f of g right there, right?
F of g minus f.
Except then you have to.
When we're doing the equations of motion, we're looking at just a single object. So if we look at just this object, I have only one force acting on it.
Oh, yeah.
This is on a different object, so that would be a different equation of motion if we wanted to write that one. So our acceleration is this way. And we established that way is positive. So what else do we need to change?
Acceleration. Right, acceleration,
How do we change it?
you just put a negative sign.
There are other ways of dealing with it, but just want to recognize, the equation that was originally written up there would have been fine if this way were chosen as positive. And I do recommend, as a general rule, make the direction of acceleration to be positive, but nothing, it's legitimate to make that way as positive as well. Negative signs cancel out, so I'm left with f sub g is equal to m times my centripetal acceleration. F sub g, we're talking about gravitational force, the generalized gravitational force. What is what's the formula for the generalized gravitational force?
M times G.
Oh. Is that what you were saying?
Yeah. Is that wrong?
What's little g gonna be?
Gravitational,
F is equal to big G M1 times M2 over R squared.
And then v squared over r. This would work if we know what little g is, but I don't know what the acceleration due to gravity is at this point. We can figure it out later if we need to. We have M1, M2. We can be more specific here. We have mass of satellite and mass of Earth. And this is mass of satellite. Let's get rid of stuff. So we now reduced it to big G mass of Earth over R equals v squared. Oh, it's v squared.
Is it always gonna simplify to that?
For the simple satellite going around the central object in 151, yeah, assuming the satellite is much smaller than the central object.
Which you're always gonna do that.
Yeah, if we had two, let's say, a binary star system where the stars are sort of orbiting around each other, that is a much more complicated problem. And so far beyond the scope of 151, unless I'm feeling inspired. Yeah, we need to cover a couple more chapters before we handle that. All right, so now it's a question of what are we actually trying, we can do one other thing, R. R is the center to center distance. So it's gonna be 2 times the radius of the Earth. So this becomes G mass of Earth over 2 times the radius of the Earth. Nope, that should be, nope, not squared, we already dealt with that. Is equal to V squared. And now it's a question of what are we actually trying to find? So let's first find how fast it's going. Let's find V. So So V equals the square root of big G, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared, times mass of the earth, 5.98 times 10 to the 24th kilograms, divided by 2 times the radius of the earth, 6.38 times 10 to the 6th meters.
Are those numbers the mass of the earth and the other number, are those numbers that are actual, just facts? Or you have to have them memorized
Yeah.
or written down somewhere?
On a test, it'd be on the top of the first page,
Right.
and on the quiz, it'd be the top of the page.
Oh,
Someone would be kind enough to crank that out.
Ten to the negative 11.
Yes. I guess we should have some general idea what it is.
And then to the right of that, are those just variables or?
What? This right here? Just units.
what is the second number on the top?
That's 5.98 times 10 to the 24th.
So this one. That's RE and ME.
Yes.
R.
5,590.983.
5,590
Yes.
point something.
Yeah.
Okay. Units?
Actually, I guess if it was rounded up, it'd be 5,591.
Yeah, but
Units?
Meters a second?
Yeah. That seems fast. How long is it gonna take to orbit the Earth? Calculate that. Well, I know how fast it's going. I know the radius of the orbit. So we just go to a classic distance equals rate times time, or rate is distance over time. V equals delta x over delta t. Not having to worry about vectors here, this is just the speed. And so, so delta t. If we're talking about one orbit, that's the period, is gonna be delta x over v. What's the distance it travels in an orbit? Not looking for a number right now, just either give me the magic word or other than please, or the formula.
it's 2 pi r normal circumference.
Yeah, so 2 pi r over v, so that's 2 pi times 2 re over v. So now let's plug and chug, so I have 4 pi times 6.38 times 10 to the 6th meters, divided by 5,591 meters per second.
Uh, 14,340.9
14,000, say it again,
340
units?
seconds.
How long is that in terms of days or hours or?
A couple.
A couple, okay.
239 hours and
Wait, no minutes.
yeah,
239 minutes?
Minutes, yeah, yeah. And then 9.9 hours.
Alright, so 9.9 hours to circle the Earth. If I asked for the period and I didn't specify how many days or how many minutes, then any one of those answers is fine. Other questions? Or questions on this?
Wait, I was like 3.98 hours, not 9 hours.
Sorry, oh. 3.9 hours. I should have thought through that. Recognize 4 hours is 240 minutes. I assume we were actually round up to 4. Issue. All right, other questions on other topics?
Slightly related, how do you get like satellite TV if the satellite's on the other side of the planet?
There are multiple satellites that are up there, so one will disappear from view and another one's in view. That's my understanding of it. And if you take 152 with me, I don't think Nassasa covers relativity.